Okay, so looking at this lessons 1 and 2 practice, this is the second page, page 7. Okay, so same thing. We got 3 that are given the equation and 3 that are given the graphs. So a couple things here, standard form. Now you have just a constant right here and then a minus 3x. So remember that x has an exponent of 1. That is technically your highest one at the moment. And you have to keep that negative attached with it. So you're going to have negative 3x to start. Keep that negative attached with it. So that then when I put the 4 after it, I'm kind of flip-flopping them, right? That's a positive 4 out front. It's just obviously we don't have to write that positive. So I'm going to write plus 4. There's my standard form there. Kind of like I said, kind of flip-flopped them, keeping the signs. So my degree here, my highest exponent, I kind of already talked about it, was a 1, which makes this a linear function. Okay, linear polynomial. Okay, and reminder, when you are given the equation, your degrees and your number of roots are going to be the same. They're going to match up. So if you have a degree of 1, then guess what? You're going to have 1 root. Okay, now your turning points, remember, are going to be degree minus 1. So I'm going to take that degree of 1, subtract 1 from it, and guess what? You get 0. All right, and think about it. A line has no turning points, right? Okay, this would technically be a negative slope, so maybe let's fix that real quick. But it doesn't change direction at all, okay? It makes it a linear, a line. So then end behavior. So reminder, 2 things you got to look at for end behavior. You're going to look at if the degree is odd or even. Okay, so I'm going to write it out for this first example, and then for the other ones, we're just going to kind of say it. Is your degree odd or even? And then is your leading coefficient positive or negative? That's what we're looking at here. Okay, now reminder, what's your leading coefficient? Remember, your leading coefficient is, when it's in standard form, it's that front one right there. There's your leading coefficient, that front number and sign. Okay, so let's answer these questions real quick. We said our degree was 1, which is going to be odd. And then look, we said the leading coefficient was negative 3 with that x there. So our leading coefficient is negative. So there's 2 things that tells us about our end behavior. The first thing is, if it is odd, then that means that my arrows are going to go in one in each direction. So you have, it could go up and then down, or it could start down and then go up. Both would be fine. Okay, so maybe I'll like actually connect them. All right, once again, this is not a cubic, this is a line, but like this is kind of general right now. And then your plus and your minus leading coefficient. For odd functions, that gives you a trend. Does it trend down or does it trend up? A negative trend or a positive trend? So what do I mean by trend is, you can kind of think about it like slope, especially when we're talking about a linear function, but it's not always slope, especially when you get into cubic functions, quintic functions, okay? But if my arrow starts up and then goes down like this, then look, that trends down. That would be your negative. If your arrow starts down low and finishes up top, that's going to trend up as I go left to right. That would be a positive leading coefficient. So since we said this was odd and negative, then that means that this is going to trend down like this. So, okay, so looking at the end behavior notation, quick reminders. X arrow negative infinity is a fancy math way of saying as you go to the left on your graph, and then X arrow infinity as X approaches infinity is a fancy math way of saying to the right. Okay, so the y's are talking about the up, down. So if I have an odd degree and my leading coefficient is negative, then that means my arrow starts up top. That means as I go left, my arrow is going up to positive infinity. Okay, now as I go to the right, my arrow is going down to negative infinity. And that's what should happen for odd functions. You should have 1 positive, 1 negative. There's my end behavior. So I know I kind of drew all over that. A lot of stuff going on there. But I want to do that for the first example so that the other ones we can kind of go a little bit faster. Okay, so for number 2, my standard form is, where's my highest exponent? It's that 5 right there. So I'm going to keep that sign with it, which is going to be a positive 4x to the 5th. All right, there is no x to the 4th, so then I'm going to go to my next highest, the x to the 3rd. Once again, I'm going to keep this negative with it. Okay, so negative x cubed. I have a positive 3x here, so I'm going to keep that as a plus 3x, and then a positive 5, same thing, keep that positive 5. There's my standard form. That leaves my highest exponent is 5, so there's my degree of 5, which makes this a quintic polynomial. And then same thing, degree and number of roots should be the same, 5 and 5. Number of turning points, degree minus 1. 5 minus 1 gives me 4. Okay, so as I look at end behavior, so let's take a look. Is this even or odd? 5 would be an odd. So once again, I'm going to have 1 positive infinity, 1 negative infinity. And then my leading coefficient is going to be, it was a positive 4, so positive. So honestly, if you refer to the last example, this is also an odd, so same thing, one positive infinity, one negative infinity. But now that our leading coefficient is positive, then this is going to be one that trends upward, a positive trend. So it's going to start down low, do whatever in the middle, and then finish up top. That is a positive trend. So that means as my graph goes to the left and to the right, as my graph goes to the left, my arrow goes down to negative infinity. And as my graph goes to the right, my arrow goes up to positive infinity. There's my end behavior. All right, so to finish up our last one, look, the negative 2x squared, that is the highest exponent. So that's going to stay right there. But then I got to flip-flop these other two. Plus 3x minus 4. That gives me a degree of 2, which makes this a quadratic. Now, the number of roots is the same as the degree. The number of max number of turning points, degree minus 1, will give me 2 minus 1 is 1. And my end behavior this time, now it's even. So quick reminder with even. Even, guys, means that they're going in the same direction. Okay, so you could have both arrows going up or both arrows going down. And the leading coefficient tells you which direction it is. Now, my leading coefficient for this one is negative. So if they're both going up, that's going to be positive. If they're both going down, that's negative, which means that is the one I want. So the nice thing about even, guys, is that both of your arrows are going to go the same direction, meaning that both of your y's, your end behavior, are going to go up to positive infinity or down to negative infinity. It's just that leading coefficient tells you which one. So if it's a negative leading coefficient, that means they're both going down to negative infinity. So I could still label left to right if I have to here, but since it's even, I know they're both going to be the same. It maybe didn't matter as much as the odd ones, the two before. Okay, so that's a bunch of information we can get from just the equation. So to finish this up, we're going to look at the graphs here. And now notice how this first question kind of, the first thing we're going to look at here is a slight difference from the last one. So look, this is asking for the number of x-intercepts or the number of real roots. So guys, real roots are going to show up on your graph. They are the x-intercepts, which is what our question is asking, right? So the number of real roots here is 3. Now, turning points is another thing you can identify from your graph, all right? Where does this graph turn? This turns, look, it shoots up and then changes direction right there. There's one turning point, and then shoots back down and changes direction right there. There's a second one, 2 turning points. Now, guys, when you look at potential degree, okay, because we're only looking at real roots, I can't always match up these two like we did in the last one, okay? So instead, I'm going to look at things like, I can look at those real roots, but I can also kind of look at turning points, and then I can look at my end behavior. So like, guys, look at your end behavior. You have one arrow going up, one arrow going down, all right? That tells you that this should be an odd degree, and then look at your turning points, 1, 2, okay? I think the potential degree here is 3. Okay, now notice how that didn't match up to our real roots. That won't always happen. Like in number 2, okay? But real quick, before we look at number 2, let's finish this up. So leading coefficient and then end behavior, they're kind of related, right? So look at my arrows here. Let's finish up this graph so it doesn't look as weird. Okay, so this graph starts down low right here, and as you go to the right, it trends upward. So look, that is a positive trend, meaning that my leading coefficient is positive. And so my end behavior, I can just look at the arrows. Remember, this is left, this is right. As x goes to the left, my arrow's going down to negative infinity. As x goes to the right, my arrow's going up to positive infinity. There's my end behavior. Okay, so number 2, or number 5, I guess, the second one of the graphs, okay? If you look at this one, there are 0 real roots here. Look, you don't hit the x-axis at all. There are 0 real roots. Now, you have 1 turning point. So now with degree, I can't really look at this for degree because it says 0, like this isn't a constant function, okay? So that's why I'm going to look at the shape, the end behavior, and then turning points as well could sometimes help me. But look, this is a parabola, guys. My arrows are both going up, so it's an even degree, okay? And with 1 turning point, I think the potential degree is 2. All right, so yeah, do these two match up? No, they don't. But remember, you can have a quadratic, a degree of 2, that has 0 real roots, 1 real root, or 2 real roots. So I still have 2 roots. It's just that they're probably imaginary or double. I can kind of see that they're not double. We'll talk about that in another lesson. So my 2 roots here are honestly imaginary. All right, but the leading coefficients, look, both of my arrows are going up. So here's a positive. And then the end behavior, okay, same thing. If both of your arrows are going up, then can you think about left to right? You could, but if they're both going up, they're both going to positive infinity. Sweet. And so to finish this last page up, okay, right here, look. If I add arrows to these, took it from Desmos, okay, couple things. One, number of x-intercepts. You have 1, 2, 3. So 3 real roots here. Now, there's a couple turning points here. Look, you have 1 turning point, 2 turning point, 3 turning point, 4 turning points. 4 turning points. Okay, so when I look at potential degree, I'm not really thinking 3 because look, remember your max number of turning points is degree minus 1. So like, this can't be 3 or even 4 because I already have 4 turning points. Like, it has to be greater than that. So I'm going to get rid of that, which tells me that there's either some double roots or triple roots in here, or there's imaginary roots, okay? So instead, let's look at our end behavior and our turning points. Look, this is an odd degree because my arrows are going in opposite directions. And with 4 turning points, I think this potential degree is 5. Okay, leading coefficient. Since it's an odd degree, 5, let's look at the trend. It starts down low and then goes up high. That is a positive trend. So here's another positive leading coefficient. And then same thing, let's look at these arrows last to do end behavior. So remember, this is one where I would probably focus on left and right. As I go to the left, this arrow goes down. So here's another negative infinity. And as I go to the right, this arrow goes up. So there's a positive infinity. And there's my end behavior. So notice the small differences between answering if we have an equation versus answering if we have a graph. But a lot of these are related, okay? Just remember, the degree and the number of roots are not always real roots. And then remember, number of turning points, okay? The degree minus 1 is the maximum number of turning points you have. There are some polynomials where, like cubics, where a degree of 3 can actually have 0 turning points, okay? So if you have a graph, you can kind of get the number of real roots and the number of turning points by just looking at your picture.